Industrial robots, a pivotal component of modern automation, have reshaped industries by executing tasks with precision, speed, and consistency that surpass human capabilities. These mechanical marvels are specially designed to perform repetitive, labor-intensive, or dangerous operations, enhancing productivity and safety across various sectors. With the advent of robotics, industries such as manufacturing, logistics, healthcare, and even agriculture have experienced a transformation, leveraging robots to optimize processes and achieve unprecedented levels of efficiency. At the heart of industrial robotics lies versatility. Robots come in various forms, tailored to meet the specific needs of different applications. Articulated robots, with their jointed arms, excel in tasks requiring flexibility, such as welding or assembly. Meanwhile, Cartesian robots, which operate along linear axes, are ideal for tasks like pick-and-place operations or CNC machining. Collaborative robots, or cobots, represent a more recent innovation, designed to safely work alongside humans in shared environments. Unlike traditional robots that often operate in isolation, cobots are equipped with sensors and safety features that enable them to interact directly with their human counterparts, facilitating cooperation and reducing barriers to automation. The efficiency of industrial robots is powered by advanced control systems, sensors, and programming interfaces. Control systems act as the brains of the robots, allowing them to execute precise movements and adapt to changing conditions. Sensors play an equally critical role by enabling robots to perceive their environment, detect obstacles, and make real-time adjustments. For instance, vision systems equipped with cameras allow robots to identify objects or inspect products for defects, ensuring accuracy and quality. The integration of these technologies has propelled industrial robots beyond simple automation, enabling them to tackle complex tasks and deliver superior results. One of the most profound advantages of industrial robots is their ability to operate in environments that are hazardous or unsuitable for human workers. In industries like mining, chemical processing, and oil and gas, robots handle tasks in extreme conditions, such as high temperatures, toxic atmospheres, or confined spaces. Robots designed for such environments often feature rugged materials, specialized coatings, and advanced mobility systems to ensure their performance and durability. This capability not only protects human lives but also expands the possibilities for industrial operations in challenging settings. The role of robots in precision tasks is particularly noteworthy. In electronics manufacturing, where components are microscopic and demand meticulous accuracy, robots perform soldering, assembly, and testing with extraordinary precision. Similarly, in the automotive industry, robots handle painting, welding, and even autonomous vehicle testing, ensuring consistent quality and repeatability. These applications underscore how robots excel in delivering outcomes that require meticulous attention to detail, often outperforming their human counterparts in accuracy and reliability. The integration of artificial intelligence and machine learning has significantly expanded the capabilities of industrial robots. AI-powered robots can analyze data, learn from experience, and adapt their behavior to optimize performance. For example, robots equipped with machine learning algorithms can predict maintenance needs, reducing downtime and enhancing productivity. AI also enables robots to handle unstructured tasks, such as sorting mixed items or navigating dynamic environments. These advancements have elevated robots from static tools to intelligent systems capable of independent decision-making. The advent of smart factories, a hallmark of Industry 4.0, highlights the interconnectedness of industrial robots within larger ecosystems. In these factories, robots collaborate with other automated systems, such as conveyors, sensors, and enterprise software, to create synchronized and efficient workflows. Robots communicate with one another using IoT, Internet of Things, technologies, sharing data and coordinating actions to maximize efficiency. This level of integration fosters real-time decision-making and enables industries to respond quickly to changes in demand or production requirements. While industrial robots bring numerous advantages, their widespread adoption has also raised challenges and concerns. One of the most significant issues is the impact on the workforce, as robots take over tasks traditionally performed by humans. This shift has led to debates about job displacement and the need for workforce reskilling. However, many experts argue that robots create new opportunities in areas such as robot design, programming, and maintenance. As industries adopt robotics, the emphasis on education and training becomes paramount, ensuring that workers are equipped to thrive in a more automated landscape. The economic implications of industrial robots are far-reaching. By boosting productivity, reducing labor costs, and improving quality, robots contribute to the competitiveness of businesses in a global market. They also enable smaller companies to scale their operations, as robots become more affordable and accessible. Moreover, automation powered by robots can drive economic growth by stimulating innovation and investment in advanced technologies. However, balancing the benefits of automation with its societal impacts remains a critical consideration for policymakers and industry leaders. The environmental benefits of industrial robots further enhance their appeal. Robots can optimize resource usage by reducing waste, conserving energy, and minimizing errors in production. For example, precision in robotic welding or painting ensures that materials are used efficiently, lowering environmental impact. Additionally, robots play a vital role in recycling and waste management, where they sort materials or disassemble products for reuse. These contributions align with the global push toward sustainability, positioning industrial robots as allies in achieving environmental goals. Industrial robots have also found applications beyond traditional manufacturing sectors. In healthcare, robotic systems assist in surgeries, rehabilitation, and drug dispensing, improving outcomes in patient care. In agriculture, robots automate tasks such as planting, harvesting, and monitoring crops, addressing labor shortages and enhancing food production. Even in logistics, autonomous mobile robots navigate warehouses, transport goods, and manage inventory with unparalleled efficiency. These applications highlight the versatility of robots and their potential to transform diverse industries. Looking to the future, the development of industrial robots continues to push the boundaries of what machines can achieve. Innovations in robotics focus on enhancing mobility, dexterity, and intelligence, enabling robots to perform tasks that were once deemed impossible. Advances in materials science, such as lightweight and flexible materials, improve the capabilities and safety of robots. Additionally, the convergence of robotics with emerging technologies, such as 5G, augmented reality, and blockchain, holds the promise of new applications and possibilities. Ultimately, industrial robots epitomize the spirit of progress, representing the fusion of human ingenuity and technological innovation. Their ability to revolutionize industries, enhance productivity, and improve quality of life underscores their significance in the modern world. As the field of robotics continues to evolve, the collaborative efforts of engineers, scientists, and policymakers will shape a future where robots complement human potential, driving progress and innovation across every facet of society.